Hello, today's lesson will be on rate, time, and distance problems. Our objective is to solve word problems involving a uniform motion. There are three kinds of uniform motions, and the first one I'm going to deal with is the motions in opposite direction. In this particular question, a bicyclist Brent and Jane starts at noon from 60 kilometers apart and rode towards each other, meeting at 1:30 p.m. Brent's speed was 4 kilometers greater than Jane's speed. Find their speeds. But in this particular case, they were away from each other. This is where Brent started going towards Jane. So this is Brent. And Jane was here going towards Brent. That's Jane. And they met somewhere in the middle. It started at noon and it ended at 1:30. So their total time they traveled is 1.5 hours. And the distance they were traveling from here to here was 60 kilometers. So the total distance they traveled is 60 kilometers. So what that means is that distance traveled by Brent, let's call that D sub capital B, and the distance traveled by Jane has to add up to a total of 60 kilometers. Now this question could be solved the same exact way had they started in the same spot, it was going away from each other, and they want to know the total distance of 60 kilometers. So whether they started in the same spot away from each other or away from each other going towards each other, as long as they're in the opposite direction, the setup should be the same, and that is the distance traveled by Brent plus the distance traveled by Jane has to add up to the total distance. In this particular case, the total distance is 60 kilometers. And the distance traveled by the Brent is, how do I do that? Well, we have to remember the formula. The distance is equal to rate times time. And we're going to shorthand that by saying D is equal to R times T. Distance traveled by Brent is equal to rate times time. But whose rate and time are we talking about? Brent's. So we're going to put a little subscript to indicate that this is a Brent's rate and time traveled by Brent. Plus, same thing with Jane. The reason why we put T sub B and T sub J is that we don't know if they travel for the same time or they traveled different amount of time. The question implies that they both started at noon and they met at 1:30, right? It's possible that Brent could have had an early start and Jane, then you would have different times. And you would put appropriate value for time of Brent or Jane, but in this particular case, they're both hour and a half. The question here implies that the time traveled by Brent and Jane is same, so let's call that T, which happens to be 1.5 hours. Okay. Now let's look at their speeds. Brent's speed was 4 kilometers per hour faster than Jane's speed. So what that means is that R sub B is equal to R sub J plus 4. Guess what? I plug it in. So what we have now is the one equation with one unknown, and we know how to solve those things. You could distribute this out, right? Which gives you 1.5 R sub J plus 4 times that gives you 6 plus 1.5 R sub J is 60. 1.5 gives you 3. And then subtract 6 from 60 gives you 54. And when you divide by 3, that should give you 18. And then to get the R sub B back, we substitute the RJ into it, and that gives you 22. So we say, therefore, Jane and Brent's speeds are 18 kilometers per hour and 22 kilometers per hour, comma, respectively. The second problem says, helicopter leaves airport and flies north at 180 miles per hour, and 20 minutes later, the plane leaves the airport and follows the helicopter at 330 miles per hour. How long does it take the plane to overtake the helicopter? So the helicopter travels this way, and its rate is going at 180 miles per hour. And the plane leaves and travels at 330 miles per hour. The problem is that they did not leave at the same time. But the question is really asking is, when does it overtake the helicopter? Meaning, at what time do they overtake it? But if you look at the picture right here, the distance they covered is the same. The distance is the same. So the main point here is that the distance traveled by the helicopter is equal to the same as the distance traveled by the plane. In the previous example, the distance of the two added up to something else. Here, the distance they've traveled is the same. So applying the formula, the rate of h times the time of helicopter as well is equal to the rate of the plane times the rate of the plane, and time of the plane, So we know the rate of the helicopter, which is 180. And we know the rate of the plane, which is 330 miles per hour. Do we know what the time is? Let's look around and, here it goes. 20 minutes later, plane leaves as well. What that means is that helicopter was traveling for a longer period of time. So the time of the helicopter is equal to the time of the plane plus the 20 minutes. Now herein lies a major issue with most students, is that the speed is in terms of miles per hour. The units have to line up, so we have to convert the minutes into hours. So this is actually 1/3 of an hour. Okay? Make sure that you have the same units. So now I can plug it in. The speed of the plane, time of the plane, we don't know, but whatever the time of the helicopter is whatever the time of the plane was plus 1/3 of an hour. If you think about it, it makes perfect sense. Because it's slower, it will take more time. So we're going to distribute this, and that comes to 180 t sub p plus 1/3 of 180 is 60 is equal to 330 t sub p, and move the 100 t sub p to the other side. That will give you 150 t sub p is equal to 60. When you divide by 150 both sides, t sub p is equal to 60 over 150, and that reduces to 2/3. So the question was, how long does it take for the plane to take over? So that we should have been looking for t sub p. If the question had stated how long does it take since the helicopter left the airport, then we have to find t sub h. So always read the question and look for what you're find what you're looking for. Well, in order to find what you're looking for, you have to know what the question is asking for. All right, guys, we need to conclude. Therefore, T sub P is 2/3 of an hour or 24 minutes. Oops. It's actually 2/5, so that's 2/5. Sorry about that, guys. And if you don't know how to convert from 2/5 to the 24 minutes, simply go 24, 2/5 of an hour, and 1 hour is equal to 60 minutes. 5 goes into 60 12 times. When you multiply that, that gives you 24 minutes. Oh, by the way, this is called scratch work, and I don't want to see in the main body of the work. You could do that on a separate piece of paper, and because I don't want it to be seen with a major work here, you need to erase that. Okay, guys? And erase as neatly as you can. That, for me, that should be good enough. Okay, guys? Thank you. A ski lift carried Maria up a slope at the rate of 6 kilometers per hour, and she skied back down parallel to the lift at 34 kilometers per hour. The round trip took 30 minutes. How far did she ski and for how long? Okay. Once again, we need to sort of have a visual help with this one. So she's going up a lift and she's coming back. So it's somewhat same as the previous problem in that you notice the distance they travel is the same. The only difference is that they're traveling in the opposite direction, but distance is the same. So we call that a round trip. We're going back and forth. It's like commuting back and forth. Okay, so we need to state the basic setup. In this particular case, the distance up is equal to distance down. Okay. Okay, so what that means is the rate going up, u, times time going up is equal to rate times going down times the time coming down. So we need to look at the informations, guys. The rate, the ski lift carried Maria up at the rate of 6 kilometers per hour. So this one is 6 right there. And she skied back at 34 kilometers per hour. So that's 34 right here. And the round trip took 30 minutes. Aha. The trip took 30 minutes, the entire trip. What that means is time going up plus time going down took 30 minutes. But once again, be careful, it's minutes, where the speed is in terms of hours. So this is actually equal to half an hour. Once you have the right units, math people tend not to write the units after that because units work out. But remember, in sciences, you really need to do that carefully. Okay, so we need to solve one of the variables. Let's go with going down. So TD is equal to 1/2 minus T sub U. We're going to plug that in. T sub D is 1/2 T sub U, and T sub U is here. So we distribute the values, which will give you 6 times T sub U is equal to 1/2 of 34 is 17 minus 34 T sub U. We're going to bring the 34 to the other side. That will give you 40 T sub U is equal to 17. And T sub U is 17 over 40. Ooh, you know what we did? We probably should have solved for the other one because it wanted to know how long did she ski and for how long. And I just realized I made a little bit of mistake in that we're supposed to look for how long did she ski, meaning time coming down. So what I should have done is solve for T sub U, plug it in, then we would have had all the time in T sub D. It's okay. So what we'll do is, it's an extra work, but we'll put this into this equation right here. So T sub D is equal to 1/2 minus 17 over 40. And that will give you, this is 20 minus 17 over 40, which gives you 3 over 40. Okay, guys. So what that means is that it took that much of an hour. So if you plug in, what else are we looking for? Yes, we're looking for how long, how far did she ski. So in order to find the distance, okay, the distance is equal to rate times time. And the rate that she was coming down at was 34 times t that we just found, which is 3 over 40. And when we do the calculation, that should come out to 2.55. Okay, therefore, she skied for 3 over 40 hour, or 4.5 minutes, comma, for a distance of 2.55 kilometers. There you go.